Hi everyone, my name is Claudia Kemp and I'm going to be going over the Module 1 written exam. Number 1 has 3 parts, I believe, and it asks to draw a graph for each of the following scenarios and explain why your graph corresponds to the scenario. So part A asks for a graph to correlate with the function of the amount of gas in a gas tank when a driver refills the tank on a drive across country. So the driver is on his drive, and as he's driving, he runs out of gas. His gas level just decreases as he drives. But then he gets more gas, and the gas level goes up, and he drives again, and as he gains more distance, he loses gas. There are 2 variables in this problem, the amount of gas and the distance traveled. So we have gas level and distance traveled. So here we see in our graph, hold on. Okay, so here we see in our graph, he's driving on his drive, and then he stops gaining distance, gets gas level increases, and then he again starts to gain distance but loses gas as he does so. That would be part A. Part B asks that we get a graph to correlate with the function of the height of an elevator stopping at each floor on the way up. So the 2 variables for this problem would be the height or the floor and the amount of time allotted or spent. So if an elevator is moving but it stops at each floor, it's going to go up really fast, and then it's going to spend a lot of time on that one floor letting people on and off, and then it's going to go up really fast, spend a lot of time on that floor letting people on and off, and so on. It's going to look like a staircase, like this. The elevator goes up to floor 2, stops for a lot of time, goes up to floor 3, stops for a lot of time, and so on. So that would be part B of number 1. Part C of number 1 asks for a graph to correlate with the function of the height of a bouncing ball dropped from a table. Now, I'm not sure if you've ever used a bouncy ball, but the first bounce that you give it, it goes really, really, really high. But the longer it's been since that first bounce, the less momentum it has, and the shorter each bounce gets as the amount of time goes on. The 2 variables would be the height of the bounce and the amount of time since the initial bounce. So it would look a little bit like this, the first bounce being really high and each bounce following being shorter and shorter and shorter until eventually it's no longer bouncing. Part D, 4 parts. A graph to correlate with the function of the length of a shadow of a flagpole throughout a sunny day. Now this one is a little more difficult to understand, and I'm not sure that I understand it correctly, but we're going to work through this. So the 2 variables would be the length of the shadow and the time during the day, the time of day. So here is the graph that is correct. And my theory, or what I understand, is that the flagpole would be right here in the middle at the top of this graph. And this, the top of the graph, instead of being the longest length, would actually be the shortest length. And then as this right here would be sunrise, and then the sunset somewhere over here. So as the day goes on, the shadow gets longer and longer and longer, and as the sun begins to set, it gets shorter and shorter and shorter once again. Longer when the sun is up, shorter when the sun is down, like that. Number 2, here, hold on. Okay, number 2, oh, come on. Number 2 says, suppose f is the tripling function f of x equals 3x, and g is the add 8 function g of x equals x plus 8. So now this problem wants us to take this certain set of variables, 0, 1, 2, and 3, and to plug them into these 2 functions and to see the relationship. So we're going to have parts A, B, C, and D. Part A is 0, part B 1, C 2, D 3. Right? And so for part A, we would plug 0 into f of x, and we would get 0 because 3 times 0 is 0. But when plugged into the g of f of x, we would get 8 because 0 plus 8 equals 8. Going on to 1, 3 times 1 is 3, but when you add 8 to 3, we get 11. C, 3 times 2 is 6, but adding 8 to 6 equals 14. And then finally D, 3. 3 times 3 equals 9. And then adding it into this function right here, 9 plus 8 equals 17. And here I have graphed them for you. You can see these 2 functions are very similar, but they are not the same. They're actually 2 parallel lines. The first line starting at 0 and the second line moved up 8 spots because it's the same function plus 8. So the lines will never touch. They will never be the same, but they are very similar with the addition of 8. Number 3, part A. Number 3 asks that we show and explain the slopes of the line segments determined by the given pairs of points. So it'll give us 2 points, and we need to determine the line between the 2 points. In each case, we need to tell whether the segment is vertical, horizontal, slopes upward to the right, or downward to the right. Part A gives the points 3, 1, and 5, 5. Now, we can tell a little bit about the slope of these lines before even plotting it, and without doing math. If the x or the y values are the same in either of the points, then the line will either go vertical or horizontal, depending on the x being the same or the y being the same. Here, neither one, the x or the y, are the same, therefore we're going to have a slope of some sort. So here it is plotted. We have 3, 1 here and 5, 5 here. So the slope goes up 1, 2, 3, 4, and then it goes to the right 1, 2. So it slopes upward and to the right. Part B has the points 5, 8, and 5, negative 8. Now, if you remember what I said before, you can tell a little bit without doing math or without plotting. If you'll see here, the x values are the same in both points, meaning that the line is going to be vertical because it is on the same x value of the graph. Therefore, it'll be an undefined slope because a vertical line is referred to as an undefined slope. So here you see here we have 5, 8 and 5, negative 8, but it's just a vertical line. Therefore, undefined slope. Part C of number 3 has the points -1, -4, and -4, -13. Now you may have noticed there are 2 -4s, but it doesn't mean anything because 1 is in the y value and 1 is in the x, meaning we're still going to have a normal slope. So you see here we have -1, -4, -4, -13. It slopes downward to the left, upward to the right, but I would say downward to the left. But it is a considerable slope for those 2 points. Number 4 asks to show and explain the graph of each of the following functions and describe the similarities and differences and relationships between the graphs. We have part A, B, and C. Part A asks that we graph y equals x squared, which I have for you here. Y equals x squared starts at 0, 0 and has points such as 2, 4, 3, 9, and so on. Part B wants this graph, but adding 7. So here you have all 3 of them. Here's the original x squared, and in the gray is x squared plus 7. You can see that it looks like the same graph, but it's been moved up 7 points. Part C is very similar as well, except instead of adding 7, we are subtracting 7. So here's the original graph. Here's part C in orange, and it's the same thing almost. It's just been moved down 7 points. That would be the relationship between the graphs. All right, number 5 has parts A and B, and it asks that we show and explain the equation of the line through the given point that is perpendicular to the given line. And it has a helpful hint. The slope of the perpendicular line is the negative reciprocal of the slope of the given line if the given line is neither vertical nor horizontal. It's good to remember. Let's move on to part A. Part A gives the line y equals -3/4x plus 5 and the point 6, -1. First, we need to find the slope of the perpendicular line. If you'll remember from before, the slope of the perpendicular line is the negative reciprocal or opposite reciprocal of the slope of the given line. So the slope is always in the m position of the equation, which is the one right before x right here. So the slope of the line is -3/4. Now, what would be the slope of the perpendicular line? Well, it would be its opposite or negative reciprocal. So the negative of negative is positive, and the opposite of 3/4 is 4/3. You have positive 4/3. Right. Next, we're going to plug it into the slope point form over here. We have y, this is an equation, y minus y1 equals m, which is slope, times x minus x1. Now the y1 and x1 are the x and y coordinates of our given point right here. So if we were to plug the point in, we would get y minus 6 equals m times x minus, y minus -1, my bad, equals m times x minus 6, like so. And m, as we said before, is the slope, so we would plug in the slope of the perpendicular line here, and we would get y minus -1 equals 4/3 times x minus 6. Simplify and solve, and we get y plus 1 equals 4/3 times x minus 9, and the final product is 4 excuse me, y equals 4/3 x minus 9. This final answer is the perpendicular line to y equals -3/4 x plus 5. 5b is a very similar problem, slightly different. It gives us the equation for the line 2y plus 9x excuse me, minus 5 equals 0. The point it gives us is 0, 3. So first, we need to isolate y all by itself on one side of the equal sign. So we will subtract 9x from positive 9x, and we will add positive 5 to -5, leaving the 2y by itself. Then to isolate the y by itself, we will divide both sides of the equal sign by 2, which gives us y equals -9/2x plus 5/2. Now we have a slope, which would be -9/2, because it is the one right before the x. You have to remember that. Okay, and then our opposite or negative reciprocal of that slope for the perpendicular line would be 2/9, because it's the opposite of -9/2. And then we would plug it into our point slope form with this point right here. And we would get y minus 3, because it's y minus y1, equals 2/9, which, you know, the slope goes right here, times x minus x1, which would be 0. Simplify, and we would get y equals 2/9x plus 3. And that is the perpendicular line to 2y plus 9x minus 5 equals 0. Number 6 is parts A through C. Part A says, show and explain the equation of the line that is tangent to the circle of radius 9 at 0, -9, and whose center is at the origin. Part B is the same, except the point is 0, 9, and then Part C wants us to compare the lines that we found in Part B and Part A. So first of all, Part A, we have a circle with radius of 9, and then it's at point 0, -9, and its center is at the origin. The origin is point 0, 0. So it wants us to find the line that is tangent to this circle. A line equation would be y equals, right? So the y equals -9, as that is the y value here. Part B is, again, radius of 9, but is 0.09. So the y equals would be 9. The relationship of these two lines, however, we can see here, is that they are parallel, because here we have the +9 for Part B and the -9 for Part A. These lines will never ever touch. They will always be opposite, meaning they are parallel lines, and that is the relationship of the two lines. So thank you so much for watching. I hope I explained things clearly for you and that you maybe learned something.